What makes a trip unforgettable? You'll know it when you feel it. Make memories with Get Your Guide. Unforgettable travel experiences.
Welcome back everybody. Just doing a quick mic test and a video test to make sure everything is okay. Welcome back everybody. Yep, that sounds okay. For those of you who are already live, one second. Yeah, so for those of you who are already here, thank you so much for being here. Just a quick mic and video test just to make sure everyone can hear what I'm saying and everyone can see my screen, which is currently on the Fusion screen. So anyone from the audience would like to give me a gentle nudge? I think there's a bit of a delay which we need to work around. Hello sir, great to see you, No Name. Thank you, No Name. Very good to see you. Very excited to be here. It's my second live. Yeah, for those of you tuning in, I'd love to know where you're tuning in from. Apparently there was a certain individual who wanted to join, but they said it was starting at 1 a.m. on in their time zone, so they might not be able to join, but very kind of them to think. And if people from around the world who are tuning in can let me know where they're tuning in from, hopefully next time I can find a suitable time that is suitable for everybody around the world. But on the weekdays, I've just come back from my work and I've just arrived home, set up the live stream, and we're on already. So that's fun. So I'll give it a couple more minutes. And while we're waiting, I'm not sure if people saw, but I had posted this post on YouTube. And it was sort of this hidden plane and it had a question mark on it. And the idea was that if somebody was able to guess which aircraft I'm about to design today, they'd get a free Fusion community session with me on Patreon, which we'll be hosting in August. So for those of you who are still here and would like to guess which aircraft I'm going to be working on today, I'll wait for a few minutes to receive some responses. And in the meantime, while we're waiting, very, very grateful for people who tuned in last time when we designed the Airbus A330. That was actually a very successful project because the idea behind making that was to actually eventually 3D print it. And after many, many design and developments and different iterations, we did manage to make it. And the person who I made it for was very, very happy to see that aircraft being made in such a small scale, and it was really, really nice. So 3D printing is coming a long way in today's date, and it's nice to be able to use it to make people happy, apart from all the impactful, positive changes we can make with design and engineering. Sometimes these things can also be used to make someone's day very, very happy. And I'm not sure if you guys saw that on Twitter. I'd posted that. And I'd also asked in the previous live stream if there were any particular aircraft or any other vehicles that you might be interested in seeing me do live. And I'd actually received some incredible recommendations. So one individual had recommended the FW190D, which is a German aircraft, which is it's an interesting one. Another person had recommended the Shrike Commander 500S. Another person had recommended the F-20 Tiger Shark. One other person had recommended a few Russian bombers and a few Russian jets. So they're very, very nice aircraft to sort of choose from and to try and model. But what I'm gonna try and do is take it at one difficulty level at a time. So all the aircraft that I've just mentioned, which were recommended by different people, are types of aircraft I've not actually designed before. So I've maybe done a few similar things, but not exactly the same. So it's going to be an interesting experience to do it live and brainstorm live in front of people, see what kind of problems I run into, and hopefully I solve them live in front of you as well. So lots to learn from each other. Um, so Nonam says, as a mechanical designer, your videos help me a lot. Thank you very much. That's very kind to hear, and it's very nice to hear that these things I'm doing on the side as a hobby is of being some meaningful value to other people. So thank you. I do appreciate encouragement, as you will notice as well. Okay, so a few minutes have gone by, and what I'd like to do is nobody's still guessed which aircraft I'm about to make today. But before I reveal that, what I want to say is the reason why I'm making this aircraft particularly as well is because similar to the A330, it is an aircraft I wish to 3D print for somebody as a gift. They don't know I'm about to do it. In fact, they probably have no clue that I'm going to do it. So it's going to be a nice, pleasant surprise. But in order to do that, I'm going to need to do some design and development. And you know, if this if this goes well, I actually have something very, very cool to announce in the coming near future. But in order to get to that point, there's a lot of design and development and failures to come across first before I can successfully launch that product. So I'm excited to share that with you. Robert Harrison says Falcon 9000. You're actually very, very close. 900, sorry. You're very, very close. It is something similar of the sort, but not exactly that one. But because you've come close, Robert, I will reveal the aircraft. It's the Dassault Falcon 6X. So that's why I said you're on the Falcon series as well. But what's going to be challenging about this one today is that I actually could not find any proper blueprints for the Falcon 6X. I found some for the 5X, I found some for the 7X, and only today I found a very low quality blueprint for the Falcon 6X. So what I've done ahead in time is I've just cropped the blueprints to ensure they're even croppable, because I use Photoshop to do this. And sometimes the quality can be so bad that I cannot detect the edges with the quick selection tool. But I managed to do it manually. I literally manually drew the blueprint out of the picture. So that was nice. But I've not set it up. There are no dimensions on the blueprints. So it's going to be challenging to set up the blueprints. And what I'm planning on doing is to look online and see what are the dimensions of the 6X and try and match the physical dimensions with the actual blueprints. And that's going to be very interesting because this is where things go really, really tough. And as I said in the previous video and in all the tutorials I've made, if your blueprints are set up correctly, then the rest of your modeling process will be a lot of fun. So let's get started. So let me just show you what I've prepared so far. So the original blueprints look like this. And as you can see, even on my screen, it's coming up as a very small picture. So you can imagine when I zoom it in, what's going to happen. You can already start to see here that there's a lot of blurriness around these lines. And that's not really a problem. But what's going to happen is when you put this inside of Fusion and the canvas is going to be somewhat translucent, even though the picture itself is quite detailed, but because the resolution is so low, we are going to struggle a bit. But that's okay. And that's why I actually took these as a challenge. My alternative was that I was going to make the Dassault 7X, which even had dimensions in the blueprints. Now that is a backup. In case the blueprints don't match up with the physical dimensions that I find online, then we are going to go ahead and make the slightly bigger version of this aircraft, which is the Dassault 7X. Okay. So, and I can show you the blueprints that I've prepared as well. So that's going to be this one. As you can see, again, this is very, very small. So if I zoom in, you can, I don't know if you can see this, but you can see where I've manually sort of cropped this out and put it in place. But yeah, the quality is not very, very good. Next one is the side view. Again, similar situation. And then we have the top view, similar situation. Now, I have made a similar aircraft in the past, but that was with very, very nice blueprints. And that was, I think it was the Gulfstream. And you can actually see that that aircraft is featured in my videos a lot. You can see it in my wallpapers and stuff. And that was a really wonderful experience. I'd made that aircraft as a very, very detailed, yep, this is the one. So this is my background, and this is one of the Gulfstreams, I believe. I'd added so much detail to this. It was quite a big project for me. But coming back to our Falcon 6X, I think let's get started. So in order to actually do this right, I've also pulled up from Wikipedia what the dimensions of this would be. Now, I've also looked at this from the actual website as well, but I just found this quick and easy. So Falcon 6X specifications. So the length is going to be 25.68 meters. The height is going to be 7.47 meters. And the wingspan is going to be 25.94 meters. What I'm hoping is going to happen is that the blueprints match up with these dimensions. Now, one mistake that I made in the previous live with the Airbus A330 is that I scaled it one order of magnitude wrong. So by the time I'd finished making the aircraft and I sent it to the 3D printer, it was 10 times bigger than what I'd wanted it to be. So to save myself from that, what I'm going to do is I'm going to first build this aircraft in 1-to-1 ratio, so exactly these dimensions. And then when I know the approximate dimensions I want for the 3D printer, I'm then going to scale it down. And then I'm going to add the little details like the windows that we worked on in the previous video. Okay, so let's get started. The first thing I want to do is import the canvas for the top view. Okay, so let's go to, just gonna take this here. Okay, so the top view from the top section of the aircraft, from the top section of Fusion. It seems like it's in the other way, so I'm going to rotate it 180 degrees, and I'm just going to scale it in an arbitrary fashion for the moment. Okay, and already, so we can already save this. So in YouTube Live, I want to name this the 6X. No Name says, it will be very difficult to design this aircraft bottom. No Name, I'm curious why you are saying that. Please let me know. Okay, so the first thing is to take this wingspan, 6X, 2594. So let's keep that number in mind. 2594. First thing, I'm going to just draw a straight line from the wingtip to the wingtip. Okay, so it seems like the blueprint might not be fully straight, or I've cropped it a little bit too much by mistake. Let's just check with this one. So if the line is at 0 degrees, then that point should align perfectly with this line, and it does. So I think the blueprint's fine. I perhaps cropped it too much by mistake. Not a problem. What I'm going to do now is finish the sketch. Again, going back to that number, 2594. I'm just going to copy that. I'm going to go back into Fusion. Right click, calibrate. So I'm just approximating that this is where the other half of the wingtip would have been. Okay, and I'm now going to say 2594, but we can see that this is in millimeters, which is not good. Let's just input that for now. And now it's gone down. But let's go to document settings, units, convert that to meters. Okay, and now what you'll notice is it would have converted it. So now hopefully from here to here, it would be 25.94 meters. No, it isn't. Okay, so after converting it, you can tell it's converted it into meters according to what its millimeter equivalent was. So let's try to scale this up again. So calibrate from that point to that point, and now this is going to be 2594. So now this is going to explode by approximately 1,000 times, because millimeter, I believe 1,000 millimeters is 1 meter. So 1, 2, 3, go. There we go. It explodes, and yep. Now that should be in its correct scale. So let's just go ahead and delete that. We don't need that sketch anymore. Okay, just checking on the chat. Everyone can still hear me and see me. Everything is okay. Please let me know in the comments. Right, insert canvas. And this time we're going to import let's import the front view. And the reason is because I want to make sure the wingspans align. So front view, so I'm going to do the front, and I'm going to scale it to an approximately correct scale. So let's say something like that. I'm going to go to the front view. I'm going to draw a new sketch to make sure that the blueprints are actually aligned correctly. Sorry, the front view is, its horizontal and vertical directions are in the correct origins. So I'm going to do from one wingtip to another wingtip at 0 degrees, and it's perfect. Okay. I'm going to now use these 2 points as a reference to then scale it up a bit. So I'm going to calibrate this front view now. I'm going to zoom in close to that point. We're going again. Paste the same number, and there we go. So as you can see, that's very, very nice. So the top blueprint and the front blueprint are very, very close. And the reason why I'm also happy to take this risk with the blueprints being of such low quality is because remembering the agenda of making this particular aircraft is to 3D print it. And so if some of the measurements are a little bit off, I'm more than happy with that, as long as the aircraft ends up looking like the aircraft that we're designing. What will be interesting to see is in the aircraft that some of you have recommended, like the FW190D, the Shrike Commander 500S, the F-20 Tiger Shark. Yeah, those would be interesting to see, because I don't know if I want to 3D print them, but I'm going to try and put some more effort in those lives to make it as accurate as I can. In fact, I did work with a gentleman in the United States Air Force who had requested a very particular aircraft from me, which was operating in the 1920s or 30s, and I had to make that to a very high accuracy. So that took me about 20 to 25 hours to make. Obviously, doing all of that at once in a YouTube live will be difficult, but it'll be interesting to see. And who knows, maybe one day I'll go live for like 48 hours and design the most accurate aircraft that I have ever designed, which would be fun. Okay, but for the time being, let's continue with this. So A330 Turbine X says, hi Tex, will this live be recorded for future? Yes, so all the lives that happen on YouTube automatically get uploaded as a video later on. So if you go to my YouTube channel and you click on the lives tab, you will see even the A330 video from last time and this video as well. So if you need some more help navigating where that is, let me know. I'll send you a link. No Name says, for me, it will be very difficult. Well, No Name, let's see. Maybe it'll be difficult for me as well, but hopefully we'll learn together. And if you have any ideas, just shoot them at me, all right? Okay, so because we're now in the correct scale, I now want to position the front view. I want to position the front view correctly as well. So what I'll do is I'll take the, I might take the nose section as the middle point of the origin. And the reason is because in this blueprints, we don't have the wheels. A330 Turbine X, I believe I also saw you in the previous live. Thank you so much for joining again. Either I saw you in that live or you had commented on the video. Thank you very, very much. Yeah, let me know if you found the video. Okay, so that's good. Now I'm also gonna try and navigate the top view to its correct position. So again, remembering that we want this to be symmetrical about this axis. So I'm just gonna gently nudge this so it's aligned to the nose. And it's also in the plane of symmetry, so that's perfect. Ikram is back. Hello, hello, Ikram. Hello to you and your family. Thank you for tuning in. Big support. Okay, so we'll take the origin off, and now I'm going to go ahead and save this file again. Okay, so we have 2 of the 3 jotted down. We're now going to place the side view as well. So canvas and the side view. And again, I'm just going to bring it about to an approximately right scale. Because remember, this project started off as millimeters, and then we scaled everything to meters, which means everything is now blown up by 1,000 times. So here's an approximate thing. And what I like to do is I like to not try to scale it to its perfect scale right away. I try to make it a little bit smaller than what I'm actually expecting it to be. And then when I calibrate it properly, I hope that everything will just fall into place. So I think I'm happy with the scale for now. Ah, Pavan is also here. Pavan, welcome, welcome. So Pavan and Ikram are 2 of my friends from work. And they helped me significantly in turning that A330 model to a 3D printed A330 model. For those of you who've not been able to see how that 3D printed A330 model looks like, you can go and check it out on my Twitter. Okay, cool. So now we need to work with the dimension to understand the length and the height of this blueprint. So we can either go for the height, which I'm not very keen on doing. And the reason is because sometimes the height is given from the wheels to the tip of the vertical tail. But sometimes it's given from the bottom of the belly of the fuselage to the tip of the tail. Whereas the length usually goes from the tip of the nose to the tip of the fuselage or the very back of the tail. So I'm going to work with the length, and then I'm going to use the height of this to verify that the front view, the side view actually works. Cool. So A330 Turbine X. This is so cool. One of the best Fusion 360 channels. Thank you very much. Very, very grateful for your comments. Right, let's, I'm just going to create a sketch from the side line, and I'm going to try lining up from there. And we can see that in this particular aircraft, that the very tip of the back of the fuselage, of the aircraft, is not actually the tail, it's not even the fuselage, but it's the horizontal stabilizer. So what would be interesting to see is when they see the length of the aircraft in this case, it could still mean that it's the tip of the back of the fuselage, but there's only one way to really verify this, and that is to just try both. So the first thing I'll do is do it for the fuselage, because that's, I believe, is the most common one. And if this doesn't work, then we'll try and go from the tip of the nose of the fuselage to the back of the aircraft, which in this case is the horizontal stabilizer. Cool. So let's do that. So from the side view, calibrate. Okay, and the value that we're looking for in this case is 2568. So I'm just going to copy paste that just to make sure there's no room for error. So 2568. Okay, we've blown it up a bit. And now we're going to position it. And now we can see whether or not that was the correct assumption. So remembering that we decided that the tip of the nose is going to be the center of our origin. So just about there. And now going back, we can see, so it actually aligns pretty well. I'm kind of surprised. So if we look at it from this view, we can see that when the tip of the nose aligns, then also very, very closely, I think there's just a little gentle nudge there that we might need to do, aligns with the back. There's another way to verify this, and that is to do the front and the right view, so we can see whether the top of the fuselage, the cylindrical section, aligns well with this or not. And I think it might be a good idea to scale up the right view just a little bit for them to meet. And that way we can also check then if the height of the fuselage itself matches with the height of the fuselage in the front section. Because remember, the front section was calibrated according to the wingspan of the aircraft. Okay, so I'm just going to edit the canvas. Okay, no, we don't need to calibrate it. We just need to edit the canvas. There we go. And I will just increase it very slightly. That's too much. So 1.025 is 2.5%. We don't need to do 2.5. Let's do 2%. Nope, let's do 1%. Even 1% is too much. So really, it's a very small amount that we need to do. So 0.5%. And let's try aligning it there. Now you can see the back of the aircraft. The red lines you can see actually match really well, as well as the fronts. But again, we just got to make sure. So let's remove the origin. And now let's do the top and right view. So now you can see that the tip of the horizontal stabilizer from the side view matches up with the tip of the horizontal stabilizer from the top view. Very, very nice. It's a very satisfying feeling when you just put in a little bit of extra work making sure these things match up. Okay, and now we can also see that the top of the fuselage from the front view is now very closely aligning to the top of the fuselage for the side view, and vice versa for the bottom. And another check I'd like to do is for the wingspan, so front view and top view. Cool. So I'm happy with that. And it seems like our assumptions were right. So we did the length of the aircraft from the fuselage to the fuselage. Now, one thing I'd like to verify just to be completely sure is the height of the aircraft, which is 7.47. Now, the way I can do that is, let me just start from the side view. So I'm going to go from here, and really I don't need to even draw this line. It's more of just a reference. So let's go ahead and do 7.47. Okay, so that's very close. You can see it's not perfect, but I'm okay with that. So there's a slight mismatch between the blueprints, but again, because it's quite minor in this case, where it doesn't really matter that much, because most of the major features that need to align do align for me, so I'm happy with that. Robert Harrison requests, would you model a Boeing 727? You do model very nice. Thank you for your time. Thank you so much, Robert. Yes, I'd be very happy to do a 727. But quite frankly, the tutorial series that I made on YouTube is the Boeing 737, and that is very, very similar to the 727. I believe the only exception would be that the 727 has three engines. So you've got two on the side and one on the top, I believe, if I'm not wrong. So you could really just follow that tutorial series and make the 727 yourself. But if you want to, if you want me to personally make that for you as a project, then please do email me. Just to clarify, to see what it is that you're asking me for. Okay, I'm just going to write that down for you, Robert. 727. Cool, I will have a look at that in a bit. Sweet, so now I can finish the sketch and we can now actually get to modeling the actual aircraft. So just as a good reference, what I like to do, as I did previously as well, is to have some reference pictures of the Dassault 6X. And as always, what we'll start with is the fuselage. So I'm just looking out for any key differences that will make this project, or sorry, this fuselage have any interesting features or not. So this is a high quality picture of the Dassault 6X. It's got a quite long front section there. I'm not sure if you want to make that. That can't really be 3D printed. There are some lights over here. Again, I believe we can add that detail. It shouldn't be too much of a problem. Let's see, anything else? So for people who are tuned in, if you find anything interesting about the fuselage that you think I should keep in mind, do let me know. It'd be nice. I'm just looking out for it myself, but I also love to have some of your input. So again, yeah, it's just those lights that are a bit different in this aircraft. And this has got your conventional airliner tail would just be a vertical stabilizer, and your horizontal stabilizers would be attached to the fuselage, but in this case, they're attached to the vertical tail. So there's nothing too crazy happening with this aircraft, except that looks like a USB slot. Okay, so again, there's nothing too crazy happening here, but I'm just going to keep this on the side just in case. So now we can go ahead and get started. Going to go to create form, cylinder, front face. And again, try and approximate where the center of your cylinder would be. So for those of you who are new, because the fuselage of an aircraft usually is quite cylindrical in nature, so it might not be a perfect circle, but it is of a circular nature. So what we tend to do is we create a circular cross-section to begin with, and then we sort of maneuver at every section or every segment along the fuselage to adapt to the actual shape of that aircraft. So I'm just currently looking at an approximate location, which could potentially be the center of the circle I create. So that's that. There we go. And again, similar to the A330 series, we have to decide whether we want to take the outer border as truth or the inner border as truth. And I tend to go with the outer border, so I might do that right now. Okay, so that's good. And let's go to the side view. That looks good as well. Again, we do want symmetry in this case. So I'm going to select symmetry and I'm going to do length symmetry. No, that's not the one. Width symmetry. So that's the one, of course. So as you can see, the green lines that have been highlighted are where your plane of symmetry is going to be. Okay, so I'm going to go ahead and press OK. I'm just going to pull this entire thing back. And you can see that because our blueprints were well aligned, you can see that approximately this already matches the side view of the fuselage. We just have to scale it down ever so slightly, which is very, very okay to do. So I'm going to go ahead and press OK and save. Again, front view, you can see that even though I selected that as the top, this is coming down a little bit. So we have to move the entire thing a little bit up. And let's see how this reacts. Okay, and now what I want to do is start scaling this down. So I'm going to remove these sections and I'm just going to start with a single slice. So we take that, right click, edit form, and now this becomes completely maneuverable to our control. So I'm going to scale this down just slightly so it matches. and I'm going to press OK. Now at this point I have to decide um, which two blueprints out of the three do I want to take as my perfect reference. What can happen often in blueprints like this or setups like this, where we only really spent a couple of minutes setting up the blueprints and it still managed to do a very, very good job. But if you want things to be absolutely perfect, you need to take a little bit more care. And in instances like this, your three blueprints won't align perfectly, as you saw with the height reference that we tried to verify with. So in cases like this, what I like to do is I like to mostly take my side view and my top view as my absolute reference points. Okay, so this means that I will try my best to satisfy all three views, but primarily I'll be focusing on my side view and the top view, again, depending on which component of the aircraft I'm working on. So for the fuselage, I'm going to be looking at the top view as well as the side view. So let's get going. Double click on the edges, right click, edit form. Again, I'm just going to press Alt on my keyboard because I'm on Windows, and I'm going to just extrude this back a little bit. Okay. People who are tuned in, let me know how you're doing, where you're from. Is there something new that you're learning in this live? Do let me know. Okay. So we're quite lucky in this instance that a majority of the chunk of the fuselage is actually very straight. So we don't have to do too much for most of the aircraft. So I'm just going to double click and edit form, Alt, drag back to extrude. And I think I'm going to go all the way maybe till here. Excuse me. And from the front section, I think I'm going to perhaps till somewhere here, maybe a little bit more, maybe a little bit less, because you can see that from here it's going to start curving inwards. Okay, very nice. So let's finish the back section of the aircraft. Alt, move, so I think we're still okay there, and we're still okay there. A little bit more. So now you can see this, as this starts to curve up, we need to start scaling this down in 2 dimensions. And if you're a little bit confused as to what I'm saying with respect to the views and the dimensions and the scaling, do watch my complete tutorial series on this. I go into this stuff in a lot of detail. So now what can look confusing for the back of this aircraft is this section over here. And it can look confusing, but it doesn't have to be. And the way I would look at something like this is, obviously I'm going to bring up some reference pictures to verify and confirm, but the way I would model this is to gradually taper this backwards, as I would for a normal airliner as well. And just think of these engines as your external engines. So you'd model the engines as a separate entity. I've seen some people try to model everything in the same form, and I think that can get very, very tricky. I personally don't like to do that. I like to make all my components separately and then join them later on. So if you remember in the A330, what we did was we made the complete fuselage, we made the complete wings, the engines were separate components, and the pylons that attached the engine to the wing was also a separate component. So they were not all attached to each other. They were separate components, which then got assembled. So in a similar fashion, this section that we see over here doesn't necessarily have to be included within the fuselage just yet. And this is my assumption. So now we're going to go and look at the aircraft itself, and we're going to verify that. Oops. Oh, hello. Nice to see you again. If you'd like to tell us your real name, and I can start calling you by that, because I remember you were there in the previous live as well, and you recommended some really nice aircraft that I could model for the next YouTube lives as well. So thank you so much for joining again. Okay, so let's have a look at the back section. So from here, there's not much information we can extract from that image. Let's have a look at maybe something of a top-down. And you can see that, yeah, we really can just taper the fuselage as we did in all our different aircraft. And these pylons, as you can call them, that attach the engine to the fuselage can then be made in a later video. Again, we can just look at some more pictures to make sure. So that's a nice one. Yeah. So you can see the fuselage is indeed gradually tapering up and gradually tapering down from there. Okay, so let's go ahead and do that. Again, if you have any separate ideas, people, that you'd like to see this happen with, do let me know. So I'm just going to start gradually tapering this down. And what's interesting is because I don't have an absolute reference as to what that curve might look like, it's going to be an iterative process. Okay, so go back another chunk, a little bit less, scale it down in 2 dimensions. Maybe that was too much. Again, remembering that when we're dealing with 2 dimensions, we're looking at the top and the side at the same time. So every time I do an extrusion and I scale something, I want to ensure that it's scaling uniformly in both the dimensions. A mistake I often made when I was coming up with this flow, which was a couple of years ago, is that I would often try and scale everything in 3 dimensions at the same time. And you can do that with this little section here. But that actually messes up things quite significantly if you don't know how much you want to scale everything with. So just to give you an example, what that would look like here is this. So you can see that entire thing is going up and down in 3 dimensions. And it kind of looks like the afterburner of a military jet. I think it looks really, really cool, but it's not useful in this case. You do not want to be maneuvering stuff in 3 dimensions all at once. So 2 dimensions at a time is good. So when we're dealing with the side view and then we scale it down like this, we're dealing with 2 different views at the same time rather than all 3 at the same time. And then when we do it from the top view, we're dealing with the top and another view at the same time. So just because you have the ability doesn't mean you need to make complex things too complicated. Okay, Alt and drag. What's also interesting to note is that our side view is really the only view that can tell us where to stop extending the fuselage, because from the top view, that gets covered with the horizontal stabilizers. So in this case, we really just got to rely on our own experience on how we want to scale in these 2 dimensions. Now it's coming quite small. So what I might actually do is gradually taper it a little bit more in a bit. Okay, let's go to the top. Everyone in the chat, okay, wonderful. So let's try and do that. And now, if I just rotate and see what this might actually look like. So I'm going to switch off the canvas. Honestly, that actually looks pretty good from the back and from the side. But I think something about this tells me that I need to make this a little bit more gradual. It feels like it's coming in as a convex and then it all of a sudden turns into a concave. And we don't really want that to happen. So I'm just going to edit the form. Now in this case, we've got to be very, very gentle with how we taper this. Because if we're not careful, it ends up looking really, really strange. I think that looks a little better. So let's have a look. Let's switch the canvas off. So side view is correct, we know for a fact. Top view also looks decent now, and back view still looks decent. Okay, I think I like that, so I'm going to go ahead and press OK. Right, canvas on, and we can now continue with the front view. So, sorry, the front section from the right view. Okay, so we're now going to start extruding this bit by bit, and we're going to follow the same procedure as we did for the back. And honestly, at this point, I've made so many different models, but every single time I have to remind myself to take it slow, especially at this stage, because these, whether we see it intuitively or not, our eyes and our minds do pick up on these subtleties, which make the aircraft look like the aircraft that we're about to make. So it's always good to invest some time making sure these features are correct. In fact, something similar is happening with the car series that I'm currently recording. It's on YouTube as well. So in those video series, we're making a Mercedes S-Class. But at the current stage of where we are, it could be literally any car. And in the last video that I uploaded, you could potentially even mistake it to be a BMW because of the way we've shaped it at the moment. So these things can be very, 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 very subtle, but then again, they decide what the end product looks like. So just sort of reinstating that it's always good to watch out for these subtleties. So in a case like this, you can see that the cockpit section sort of comes down like this, and this a bit of a stop somewhere here in the blueprint, and then again it gradually goes down. But in the cases of the Boeing 787 Dreamliner or the Airbus A220, the entire thing is very, very smooth. So there's no sort of break point in a case like this. And those are defining features of how the aircraft looks like. Okay, so I think I might want to make this a little bit smaller or bring it down a bit more. So either we do that or we patch it up at that section and then we loft the rest of it. So let's see how this would look like if we just continued. I have a feeling it's going to look a bit strange. So let's stop it there. Let's turn the canvas off. So you can see that it is evident that there is a turning point here that's sort of going from one gradual gradient to another. But I don't think it's as defining as I'd like it to be. So we hide the bodies. We can see that it kind of comes to a stopping point somewhere there. I believe there is a way around this. So let me just undo to the point we went there. And I think the tool is Control, oh no, let's do edit form first. Control Alt drag, there we go. So that is now giving me a not so smooth extrusion. So watch how the difference goes. And this is brand new, I've never covered this before. So I selected, and usually what I do is I just press Alt on my keyboard and I drag. And what you can see is what the form tries to do is it tries to create this continuity over here to make it as smooth as possible. But if I undo that and I press Control Alt and I drag, you can see that it doesn't care about continuity. It will literally just extrude it in that particular direction. So what I'm going to do is I'm actually going to just try that out, and I'm going to I'm genuinely not sure how this is going to end up looking, but let's have a look. And now I can just go ahead and do Alt, which is our continuity extrusions. And I think I've forgotten to actually edit this bit, so we need to do that as well. Okay, so let's do that and let's finish the form and let's have a look at how this looks like now. So canvases hide, and that is starting to look like a duck, which is not very nice, but hopefully when we make the nose, it will start looking more like the aircraft that we're actually trying to make. So if we bring the canvases back on and go to the front view, we'll see that even though we didn't explicitly work on the front view, the blueprints are being matched by the model we created. And this makes sense because when we scale in 2 dimensions from the right view, we're changing the right view as well as the front view at the same time. Then when we're doing it from the top view, we're changing the top view as well as the front view. So in a way, we've maneuvered the front view without explicitly doing anything from the front. So if 2 out of 3 things match, the third thing you'd hope also matches. Especially when you've maneuvered it in 2 dimensions at a time from the front, from the side view and the top view. Hopefully that makes sense. Let me know if it doesn't and you'd like me to explain it a bit more. Okay, so let's go ahead and patch up this body. So you can see that currently this is a surface, it's orange. And what we'll do is we'll patch it. So let's go to surface, use the patch tool, patch that. And now I also want to patch the front section over there. So if I had the canvas, what you'll now notice is that there are 3 bodies, which are 3 surfaces. And we can now stitch these surfaces together because essentially when we created this cylinder, it was hollow. It's just a thin wall with no thickness to it. So it's just a surface. And to turn this into an actual solid body, we need to either cap the 2 ends to make it a solid body, or we, it's just giving me an error, sorry. Or we take the surface as it is and then we apply the thicken tool to it. But obviously in this case, we want to solidify the whole thing. So I'm going to press 1, 2, and 3 and press OK. And now you'll see the 3 surfaces will go away and it'll be turned into 1 body. Wonderful, I'm going to save this now. Bring the canvas back on. can see that I think we missed a little bit of the curve there. So what I might do is I might go back and edit that. Okay, that looks a little better. And if we're still not happy with it towards the end, then we can come back and change it a bit more. Okay, so I'm going to create a sketch on the back of surface that we just created. And this is because I want to split this very back section into two symmetrical halves. So I'm going to press P on my keyboard to project. I'm going to click on specified entities and I'm going to press that one. Press OK. L on my keyboard to press a line. And guys, all of this is covered in the tutorial series. So really, I'm just doing the same stuff that I did there, but in a slightly different model. So if I come across anything that's more interesting, I'll make sure I mention it. But I'll talk out loud just to make sure people are following. Okay. Now I want to project this bit here. I want to project the body. Okay. And I'm now going to create a control point spline. So just something like that. And again, if you have any experience with splines in Fusion, you know that Fusion tends to crash when working with splines. So anytime I'm working with splines, I tend to save just before. Okay, finish sketch. And now we're going to try and loft all these three together. So create, loft, 1, 2, nope. So it's 1, 2, and 3. So let's cross our fingers and pray that it will work. 1, 2, 3. Wonderful. Again, this is usually where a lot of people's problems come in using this lofting section here, because either the proportions are completely out of place or there's not enough geometry to wrap into a loft. So we really got to play around with the sketches, make sure one thing is not extra long and it's completely disproportionate to the other sections that we're trying to loft. Okay, now I'm going to repeat the same thing for the front section, and I can see that there might be a problem lofting this front section, and if there is, then we'll solve it together. So project, specified entities, the front section, symmetrical. And now let's turn it into two symmetrical halves. Create sketch on the left plane, project your main body, canvas on, and now we're going to try and follow that path over there. So create spline, control point spline. Of course, you can use any kind of splines you want. I think in this particular case, you could even use a conic curve, but I'm going to spare myself the trouble there. Cool. Now let's try and loft that as well. So 1, nope. And you can see sometimes we may not realize, but we would have selected something and tried to loft a whole surface with a point. And believe it or not, it's actually possible. So if I were making a MiG-21, for example, I would have done something like that. But in this case, it's wrong, so we shouldn't do that. So make sure nothing is selected. Make sure you press escape to ensure that nothing is selected. Create loft 1, 2, and 3. Okay, so in this case, it actually worked pretty fine as well. Excuse me. Okay, how are we doing? Sometimes I forget I'm live, which can be fun. Okay, so I know that from this section, it looks a bit strange, but again, I'm hoping that as we move forward and we start adding more details to it, it's going to start looking like our actual aircraft. So I'm going to go ahead, press save. Cool. Now, the next thing we want to do is make the wings. So let's have a look at the wings from the side, from the front view. And we can notice right away that the wings are actually just completely straight. There's no dihedral, no anhedral. What is interesting to note is that your horizontal stabilizers have an anhedral. So if you don't know what an anhedral dihedral is when your wings or your surface sort of is inclined to your fuselage, so there's an upward angle, and your anhedral is downwards. And these angles help in stabilizing or destabilizing an aircraft. So, for example, your airliners can be are very stable. You want them to be stable, but you also want them to maneuver. So by design of an airliner by default would be a little bit unstable, and to add stability to it, you'd pull the wing up. So if you ever look at an airline from the front, you'll see the wings going upwards. Whereas with your military cargo aircraft, you'll usually see an anhedral at the back, like this one over here. So your stabilizers are actually going down, and the reason is for that is because by nature of their design, the aircraft are so stable that even if you wanted to move a little bit, by default your aircraft will come back. So in order to destabilize your aircraft a little bit, so you can actually turn a little bit and go in the direction that you want to go, you need to perform a few engineering gymnastics, as we call them, to be able to achieve that. But in this particular aircraft, the wings seem to be completely straight. So what we'll do is we'll go to the top view, and we're going to try and trace out where our airfoil chord line would be. So I'm going to create a sketch from the top. I'm going to do a line from here to here, from here to here. Okay, cool. So we can trim that away and that away. Sorry, we need to trim that away. Now we can trim that and that away. Trim, trim, trim. And now we have this line over here. So that line can tell us how big our chord line should be. So let's finish the sketch there. And it seems like we need our airfoil section to be starting from a lower height, but that's completely okay. So what we can do is, I don't know if you can hear a baby crying. Okay. That's a bit funny. Anirudh Chhatri says, I'm RC Aero Modeler. This will help to design RC plane fuselage. Thank you. Well, thank you very much, Anirudh, for your kind words. And if you have any pictures of your RC plane, please send them over, email them to me, or send them to me on Instagram. I'd be very, very happy to see them. Okay, so we've just created a sketch on the side view. And what I want to do is I want to project this line over here that we just created. And the airfoil section needs to be a bit lower, as we said. And because this is, again, because I'm making this for 3D printing, I think it would not be good to use the actual airfoil that this aircraft uses, but I'm going to come up with an arbitrary wing airfoil shape. And I'm going to make it quite thick, because when we 3D print this at a miniature scale, the thickness of the wing really, really matters. Because your 3D printer nozzle has a fixed thickness, and if the wings are too thin, it will literally not print the wing. And I've experienced this a couple of times with Ikram. If he's still in the chat, I'm sure he'll be able to tell you. So we're going to try and come up with an arbitrary airfoil shape in this case as well, and then we're going to try and make it a bit thick. So create spline. Actually, before I do that, I'm just going to create a construction line down a little bit. So somewhere there. And now I'm going to create a normal airfoil. So spline, control point spline. Again, just trying to be extremely as thick as possible. And then I can just go ahead and mirror this. So mirror line, finish the sketch. And it seems like because of how thick we've made it, the wing's actually coming out of the fuselage. But that's actually okay because we still have the wing box that we need to eventually create. So for now, I'm going to leave it as it is, even though this really doesn't look like an airfoil. But I'm going to leave it as it is, and we can come back and edit it later when we create the wing box, and if there's still some things that are not looking good. Okay, just to make sure, I'm going to go ahead and save this. And we have our chord line ready. And I'm going to construct a plane at an angle and use that chord line. And in this case, it's completely 0 degrees. So we don't need to create any sort of anhedral or dihedral. Welcome to everyone new who's joined. It's really nice to see the number of people streaming in is increasing. So thank you very much for being here. All right, cool. I'm going to project the chord line that we created. And because of how we created the reference chord line even before we made the actual chord line is dependent on where we were estimating the wing section to stop, we're now expecting the wing to look quite smooth. So just going to create a line there, snap on, tip to tip, and maybe we can end it somewhere there. As for this one, we can go, there's a little bit of a curve over here if you notice it. So if I try and do a straight line from here to here, you'll notice that the wing is not actually going straight, it's going a little bit inwards before it then goes outwards again. So let's follow that same path. Cool, finish the sketch. And now I will sweep. So we'll sweep that section. We need a path and a guide rail. So path is going to be this one. Guide rail is going to be this one. Okay, so it's telling me that the path is not smooth. Try modifying the path. Oh, wait, you can't see the error. There we go. So the path is not smooth. Try modifying the path so that all the edges are connected with tangent continuity. To create a swept shape with a sharp edge, try using multiple sweeps. Okay, so this makes sense. And the reason is because the primary path that the sweep is meant to rely on is not smooth. As you remember, we just created this sharp line here, and then we created another sharp line, and there's no smoothness between it. It's sort of like if you zoom in, it's going to be like this, and a path cannot be created based off that. If there's a guide rail that has a sharp edge, that's completely fine. So I'm going to cancel this, and I'm going to go back and try and edit this one. So oops. I'm going to try and edit the sketch here. And in this case, it's actually a really easy fix. We can quite simply just create a fillet over there, which is going to be a very gradual, smooth edge there. And what that will allow to do is that line and that line now have an intermediary line, which both of them are connected to using tangents. And now, because of that, we're hoping, fingers crossed, that the whole wing is now going to be smooth. So let's finish the sketch and try and sweep that again. So sweep, guide rail, path is here, guide rail is here. Okay, perfect. And again, it's showing us red initially because we're sweeping from the plane of symmetry and the fuselage exists just outside it as well. So by default, it's trying to cut through, but what we'd want to do is actually new body. Okay, and we can go ahead and press OK. Oh, actually, we have to pay attention to the wingtip. You can see that it didn't go all the way there, and that's fine because we need to do full extents. Press OK. Wonderful. So I'm going to go ahead and press save, and I'm just going to take a 1-minute break, and I will see you guys in a minute. Mic test. So I'm back. I just had to use the washroom for a bit. If you can hear me, please let me know in the comments, because I did I muted and then I unmuted my mic. So if you can hear me, please let me know. I'm going to assume everything is okay, and I'm going to continue. Okay, so we just created the wing, and let's switch off the canvas and see how that looks like. Okay, that's good. I think what I want to do now is perhaps it'd be a good idea to create the empennage sections. So the first thing we need to do in this case is we can't actually make the horizontal stabilizers before we make the vertical stabilizer. So what I'll do is I'll create an approximate vertical stabilizer, again using an approximate airfoil section, and we're going to sweep it up like we just did for the wing, and then once that body is created, we can then go ahead and create the horizontal stabilizers. Okay, so let's do that. So I'm going to start from the side view actually to try and trace out an approximate path. So press L. And again, because we're 3D printing this, I don't want to do this curvature over here. I'm going to just go straight down. And from here to here. And then I'm going to create a reference line there. So I'm just going to select that and create a reference line, or a construction line as we call it in Fusion. And finish the sketch, construct, plane at angle, press that one, 0 degrees. And I'm going to now create a sketch on this plane. Might be a good idea to project our line. Where is that line gone? So if you can't find the line, there it is. I just switched off the visibility for the body so I could find the line again. There we are. Press OK. Okay, spline, control point spline. Again, just making it as thick as I can. Okay, come down. And you'll see why, because when we scale this down, hopefully in the next hour, we'll be able to see why it was necessary. So create a sweep, path and guide rail. So path is smooth, guide rail is also smooth. So there shouldn't really be a problem. So the profile is going to be this one and this one. Okay, there we go. And we need it to be full extents, and we need it to be a new body. There we go. Let's hide the canvas. Okay, that's coming together well. Let's bring back the canvas. And what I would like to do is, as a defining feature of this aircraft, I would like to actually create this little section over here. So let's go to Google and see what this section looks like. Okay, so it's really just another aerodynamic surface on the top of that. So I think we can go ahead and create that. It shouldn't be too complex. I think what I'm planning to do is first create a patch on the top, and then perhaps offset, make a line, and then create a sketch, and that will revolve around its own axis. So let's see if we can do that. But before we jump to that, I want to create the horizontal stabilizers, and that can be done on this plane. So what we can do, because remembering we actually need to create a anhedral. So what I'll do first is, from the top view, I'll create a reference path just to try and locate where our airfoil will actually be placed at the center if it were to be projected in this sweep. Okay, and then I'm going to go back to my reference, which is here. Sorry, my plane of symmetry, which is here. There we go, and now we can take all of these out. So 1, 2, 3, 4, 5, 6. There we go. So that's where our line needs to be. Cool. And yeah, so that's from the top. But we also know that we need our we actually need our chord to start from somewhere here. So I'm going to project that line that we just created, press OK. Take it up a little bit, take it up a bit more, so somewhere there. And now this line can then be used to create our plane that we need to construct off. So plane at angle, use that. And let's try and put it down by 5 degrees. And once we sweep it, we'll understand whether 5 degrees was a good idea or not. In general, I just try to do 5, 6, or 7. I think 7 is looking more promising. So I'm going to do 7 degrees. And now I'm going to create a new sketch. Actually, before we do that, we can actually edit the sketch and create the airfoil here itself. So we don't need this line or this line or this line. And again, I'm just going to create an arbitrary airfoil section, and I'm going to make it as thick as I can. But again, relying mostly on the thickness in the front to make it look like an airfoil. So then we're going to mirror this and finish the sketch. Okay, we are 1 hour 15 minutes in. Thank you all very much for staying. At this point last time, I think there were only 3 or 4 of you remaining. We have 9 right now, which is I'm very, very grateful for. Okay, let's continue. I think we needed that plane actually. So let's do that. Create a sketch on that plane. I'm going to now project the chord line, which we need to sweep off. And go to the top view. Create a line from here to here, and from here to here. Cool. So it's pretty straightforward. We've done this many, many times now. 1 and 2, path is this one, guide rail is this one, and new body. There we go. So pretty much we have the, no, actually we don't. Apart from the engines and stuff, we pretty much have the main components of this aircraft ready. And if I were to put it into perspective, and mirror these bodies. You can see that's already starting to look like a private jet. And it's interesting because there's still no detailed defining features of this particular aircraft, but just by the sort of proportion of the wingspan and the fuselage length and the height and the configuration of the wings and the tail, you can already tell it's a private jet. That's very, very interesting. For those of you who've done aeronautical engineering and have designed aircraft in the past, it's possible. I may be completely wrong. It's been a couple of years since I graduated. Actually, it's been 2 years since I graduated. But usually for different specifications of aircraft or your different mission profiles for your aircraft and the different type of customers you have, there'll already be a sort of somewhat of a set idea of what your aircraft is going to end up looking like, unless you're going for something completely extraordinary, which has never been done before, which is also very, very cool. Okay, let's get back into making some more defining features. So I'm just going to undo the mirror because I thought it was a cool thing to show. Orthographic. Now, at this point, there are two things we can do. We can either create the wingtips or the horizontal stabilizers ends or the vertical stabilizers ends, or we could actually go ahead and create the engine section. So what I'll do is, just to be sort of continuing with the theme of creating the major components first and then adding features later, let's actually make the engine first. So I'm going to go ahead and switch the canvas back on, and we know the approximate location of the engine is over here. So what I need to do is, from the side, the first thing I want to check is the engine inclined? Because again, if you've done propulsion or or like any sort of engine design as well, you'll know that there's also some sort of an inclination that engines can have with respect to the horizontal. So what I want to do is approximately just take a straight line, and you can see that in this case the engine has a little bit of an incline. So if I draw a straight line that is horizontal from the center of the engine from the front, and I drag it backwards, you'll see that it's not actually meeting the center of the engine over here. In fact, let's see what angle this is. Where is the angle? Okay, interesting. I don't know what angle that is. Let's try and inspect between. Okay, it's about 3 degrees. This may not seem significant, but it makes a massive difference when it comes to you doing the thermodynamics behind engine design and the overall performance of the aircraft. Okay. The question that's running in my mind right now is, should we take it the easy way and just make it normal, or should we make it inclined? You know what? Let's do it a bit challenging. Let's try and keep the incline. Okay, let's keep the incline. So what I'll do is, since we already created the reference line for the incline, I'll keep that as it is. And what I can do from here is I can actually use this line, even though it's already in the plane of symmetry. I can use this line to create the engine and then move the actual engine component into position. Or we finish the sketch here, and let's do this the proper way. Let's create an offset plane from the plane of symmetry, and let's drag this so we have an approximate location over here. So 230 doesn't work, 225. Oh, there we go. Perfect. And on this plane that we've just created, I will project this. And what I can do here is, we don't need to create any planes at angle at this point, because it doesn't have any anhedral or dihedral, but it does have an incline here, which we've already taken into account. So let's create a line, and it doesn't need to be vertical up, it needs to be perpendicular to this line. So that's what that square 90-degree angle is showing. So let's do that. And then I'm going to create a spline from here, here, here. Save, because we're using splines. And again, just perpendicular. Okay, perfect. Let's bring this down a bit. And as it is, we could sweep this away, but we need this to be a bit hollow if we want to print out the fan. So what I'll do is I will create an offset for this. So we can make it maybe 0.2 meters. Something like that is nice. And obviously, if we want, once we scale it down and we need to increase it, we absolutely can. Okay, that's perfect. And this is now a surface which can now revolve around its own axis. Cool, so let's do that. Let's finish the sketch. Create, revolve, use that. Axis is this one. And we're going to do new body. Now, it's interesting, if you noticed, it was asking us to be able to cut into something. And you can see there's actually a bit of interference between this one and this one. I believe there is a tool we can... Yeah. You can see that red highlighted area there means that these two bodies are clashing. And that should never happen. So my assumption here is that in reality, what would have happened is that the fuselage, starting from this point over here, so remember that when we created the fuselage, the back of the fuselage, we tapered it very nicely back into its position. But what is also possible that, if you see that line there, that there was an abrupt change in the width of the fuselage, and then it gradually tapered back down. And that abrupt change would have been where this engine currently is. So if you follow my mouse, it would have been something like curve in, and then it goes back like that. So if we wanted to, we can actually try and do that now. Because if we go back and edit the form, you'll see we still have that sort of projection of our engine. So let's see if we can try and do this. And if it doesn't look good, we don't necessarily have to do it again, because this is for 3D printing. But just as an experiment, I want to try and see what would happen. Okay, let's keep that. And now let's do finish form. And now you can see there's quite a bit of clearance between the fuselage and the engine. And now that I remember, the Gulf Stream that I had made actually did have something similar here. So if we actually go down here, I don't know if you can tell, but there would have been a bit of a curvature going inwards. So let's keep it like that for now. If we don't like it, we can just undo it. But in order to see whether it even makes sense is to make this pylon between the engine and the fuselage. So just making sure people are okay. Cool. Yeah, so now let's go ahead and create the pylon. And the pylon can be made in a similar fashion to the wings and the empennage sections that we've already created. Okay. Again, guys, if you have any questions, please do post them in the chat. There are a few of you on the chat, but no interactions. So hopefully I've not made you guys fall asleep. If you have any questions, if you have any recommendations, anything you'd like to say, please do post them in the chat. Okay, cool. So what I want to do is perhaps look at a more smoother way of creating this section here. So if we look at some more images, hopefully that will give us a little bit more idea. So this image over here. Really, it just appears to be a pretty straight line over there. And if you look at it from this section, it's also a pretty straight line here. So I guess what we can do is we could just connect it in a smooth line. So it's going as the bigger section towards the engine and then going inwards towards the fuselage. So actually, I'm not sure why the blueprints is showing it like this, but in the real pictures, it's going a bit inwards, it seems like. So let's try that and see what happens. So we'll create a line from here to here, let's say. Can you convert 360 format to Blender? Yes. I think Fusion is known to be able to accept and export many different file types. In fact, if you go to File, Export, you'll see that you'll actually receive a lot of different types. I think depending also on your license type. So this is new for me. I'm not sure what that is yet. But if you then look at what kind of files Blender can accept, mostly all 3D softwares can accept STL files. I think OBJ is another common one. FBX is a common one. So have a look at what, Blender can accept, and I'm sure you'll find a way to export something from Fusion to Blender. Okay, so let's do that. Bring it up a bit. And if we wanted to, in this case, we could also add an incline to this particular line as well. So maybe somewhere there. Let's create our streamline body, which is going to be a thick airfoil. So something like that. Mirror it. So fun fact, most wings are not symmetrical. So you see that I created this top section here and then I mirrored it down, but most wings aren't like that. Your vertical stabilizers and your horizontal stabilizers, I think most probably are. Okay, so let's finish our sketch there. And let's add a plane at angle from here. And let's see if we can spot, it doesn't look like there's much inclination from this view. The only inclination for the engine is from this view, which we've already taken into account. So let's do OK there. We'll project, we need to create a new sketch on there. So we'll now project this one. And create a line from there to there, and from there to there. Again, we're just now going to sweep this. So 1 and 2, path is this one, guide rail is this one, new body, press OK, canvas off, save. Okay, so at this point, I can say that majority of our components are done. We haven't yet made the wing box, but as it is, if you wanted to 3D print this or create some sort of design of this, you already can. But what I'll do now is I'll start working on adding some details, and then we can add the wing box after. So I think the most simplest thing to do would be to close this one over here. And the way to do that in a simple manner is to just, and this would only work if your airfoil was symmetrical, is to create a sweep. To revolve. So now this and this are split. Finish the sketch. Not sweep, sorry. Revolve from here, and the axis would be this one. And new body, there we go. There we go, it's that simple. Obviously, it's not the best rendering. You can see that it's coming down a bit and then it sort of bulges as a vertical thing. But again, for 3D printing purposes and for the size I'm making it, I'm completely fine with this. But a little bit more detail needs to go into the vertical stabilizer. So as we said, we wanted to create somewhat of a bulge. If we look a bit closer. So it really does look like a half of an airfoil that has been revolved 360 degrees, similar to what we've just done for the tip of this. However, it seems like it was done in a slightly different manner. So what I'll do is I'll create a sketch plane of symmetry. I'll create a horizontal line from here to here. And then to do a very simple one, maybe something like this. Sweep axis is this one. There we go. So that's pretty much what it looks like from my view, except there's a bit of it does, so the vertical tail extends into it rather than that sitting on top of it. It feels like that. So what I'll do is I might just be able to press pull this a little bit above till it reaches that point. So I think that actually looks very, very close to what we're looking for. So I'll end it there, but we'll edit this sketch so it looks a little bit more like what we want it to be. So maybe we need to add another point of the spline in here. So let's create a new point somewhere here. Create point somewhere here. Let's see if we can maneuver this. No, we can't. So I'll just have to cancel that. Not a problem. We just have to create a few extra lines. Points. So 1, 2, 3, and 4. That's what I want to do. That already looks pretty smooth as to what I want. I'm going to finish the sketch, and there we go. Okay. To make it a little bit better, what I might do is put this back a little bit. So we're going to try and estimate where this is going to come up, and it's going to be somewhere here. So I might just do that. Finish sketch. Oh, very, very close. Okay, we can now try and press pull this up a little bit more to see how it looked like. And to now add a little bit more sort of, because you can see there's a bit of a split there. What I might do is I might project this back parallelly. So make this line parallel to this line. And now you can see this is actually where it's meant to come. So I might snap that into place. And now finish sketch. And now you can see it's very, very close. Now the only thing we need to do is drag this one a little bit more up. So not 0.3, not 0.25. Let's try 0.275. Nope. Okay, 2.8, 2.85. Perfect. There we go. Look at that. So let's save that. And again, we could have actually done something even smarter, which is to make it a little bit more accurate to what we want, and we could have lofted half of the surface to the tail. But again, when we shrink this down, you won't be able to tell the difference at all. So I'm happy with this. Let's close our canvas. That looks starting to look pretty decent. So we got that covered and that covered. Now let's now that I remember, these are still surfaces, so we need to patch them and turn them into solid. So let's do that before we forget. Okay, now that is a solid. Patch that one, press OK, stitch that one, and that one. Cool. Cool, so now let's do the wingtip canvas. And the wingtip's going to be interesting because it is quite literally 90 degrees up. So, similar to what we've done before, we could just create a 3D spline and have that follow that. But if I also remember correctly, it is going backwards as well. Yeah. So we can't just do it as simply as that. Let's then create a 3D sketch. So create a sketch on the tip of that. Let's bring back our chord line, which we will refer everything towards. Right. 3 sketch, spline, and we're gonna go from side there to somewhere there, and then we're gonna move this a bit to the side. And we need to now activate tangent, make sure that's actually a vertical, and activate tangent there. And I don't want to enforce horizontal here, but I'm going to try and approximate it just very quickly. There we go. Now if we go to the back, we need this to now come somewhere there. And now I can no longer have this vertical constraint here, because if I try to move this, it won't let me. So sometimes what I do is I add the vertical constraint just so it becomes vertical in one dimension, and then I just remove the vertical constraint, and then I can maneuver it freely as I like. But you'll notice the advantage of that is if I come back to this view, it is still a vertical. So that's nice. Now here, as for this one, we can see that from this angle, from this view, we have a slight angle for that tangent. But from this view, if we pull it sideways, it won't affect how it looks like from the front. So remember how it looks like from the front? It's sort of inclined in this way. And now if I pull it back, nothing should actually happen from the front view. There we go. Absolutely nothing's happened. And this is because we didn't move it up and down. We moved it sideways. And from this view, sideways is in and out. So absolutely nothing happened from the front view. So it's nice knowing these little tricks. Press OK. To people watching in the future, I know some of you have requested me to create a specific tutorial for airfoil section, for wingtips using 3 sketches. It is on my list, but the first thing I'm going to do is finish the car tutorial series because people have been waiting for that as well. Of course, if there's anything specific anyone else would like to see as well, please do let me know. Okay, so in a similar fashion, I think what would be nice is to have this at the same height as that one. So I will do something like this. Okay, so it's approximately in the right place. I cannot let both of them coincide, unfortunately, because that would coincide them in 3D space as well. So I'm going to take that and I'm going to move it in that direction. And from this side, we need to pull it back a bit. So we need to do something like that. And once again, take that, turn it vertical temporarily. and take this one, activate tangent handle, move it down. Because from this particular view, it seems like they both want to go in the same direction. But from here, we need to change this so we can do in and outs. So, of course, we need to delete that constraint that we added temporarily. We can now do that, but we can't do it too much because it'll come up with that interesting curve. But we can do this. So let's press OK. And let's try sweeping this now. So sweep. Profile is this and this. Path is this. Guide rail is this. There we go. And press new body. That's your wingtip for you. Let's hide the canvases. And look at that. That's starting to look really, really nice now. Really, really nice. To make it look even better, we can do perspective, mirror, this, and that. Mirror plane is this one. That's starting to really come together. I'm actually quite happy with that, even though we've still not really added too much detail. So this now looks like a generic private jet. But now we're going to make it look like the Dassault 6X. Cool, so let's continue. I'm just going to undo the mirror, come back to orthographic, make sure we can do some more stuff. Okay, so we've covered the wingtip, we've covered the tip of the vertical stabilizer, we've covered the tip of the horizontal stabilizer. I think now the only thing that's really left to do is to create the flap track beam that will help us, the wing box, as well as the details on the fuselage. So stuff like the windows, the doors, so on and so forth. But as I said before, I don't really want to do that in this scale. So what might be a good thing to do is to create the wing box first, because that, regardless of the scale, will always look the same. And then we can scale it down to the size we actually want it to be for the 3D printer. And then I can start adding the windows and stuff, because what happened previously was I created the windows, and then when I embossed them, they didn't reflect at all in the 3D design. So I had to really emboss them much more in order for them to be even visible. So I'm going to skip the fuselage details for now, and I'm just going to concentrate on the wing box. Okay, so one thing I think I've completely forgotten to do is to spread out the blueprints. So I'm just going to go back to this. Canvas is here, sketch is here. So I'm going to go back all the way, construct, plane 24 meters away, another one somewhere there, and another one somewhere here. So if you've watched my tutorials, you know why I do this. It's because it feels like the blueprints can get quite cluttered, and you don't want them to be too close to each other like it is now. So it's nice to have all the blueprints close to each other initially to make sure that they all match up correctly. But when you're actually modeling, you want them to be away from each other. So edit feature, you can go down. This one, edit feature, you can go to the back. And this one, edit feature, you can go to the side. So now you can see everything's like quite separated, which is nice because you can see stuff clearer now, at least from the main body's perspective. Okay, so I always tend to struggle with the wing box. So for those of you who don't know what the wing box is, the wing box is basically this belly situation over here that connects the wing to the main fuselage. And every single time I come across this, every single time I forget how I did it the previous time. I have a vague idea, but I'm not sure if it's exactly what I did previously. I know what I'm about to do is going to work with some fine-tuning, but I keep forgetting what I did the previous time. So let's just go ahead and do it. So what I need to do first is I'm going to split the wing somewhere here. and then I will create a connector. So I'll separate the wing here, and then I'll create some sort of a section at the plane of symmetry, and then I'm going to loft them. I think that's actually what I did last time as well. I think the method works. So I'm just going to split it maybe somewhere over here. So split body, splitting tool is going to be that plane we just created. We don't need this one anymore, so I'm going to remove. Now, in an ideal situation, and I highly, highly recommend this, as you create the bodies, I think you should start naming them, because otherwise it's going to start getting really confusing. So this stage that I'm at right now, it's okay because you can literally count how many bodies there are. But when you start adding complexity to it with different components, and when you start making it more detailed and you need more parts, then always a good idea to name your bodies, and to take it even a step further to create components. So when I start doing 3D printing related things, I usually turn everything into a component because I need specific things to be a certain way, certain colors, and so on and so forth. But for now, I think we're okay. So construction, we don't need that plane anymore. And I'm going to create a sketch, plane of symmetry, disable 3D sketch for now. And I'm going to create a control point spline. As always, guys, if you have anything to add, you'd like to ask a question, you'd like to comment on something I'm doing or the particular way I'm doing it, please do let me know. Hopefully you've already liked and commented and subscribed, because that does help me out. We are trying to make it to 5,000 subscribers by the end of this year. So if you could contribute to that, you'd like to share this channel with your friends and communities that you're part of, that would be very, very much appreciated. Okay, let's continue. So if we remove the bodies for now, what I'll do is I'll create an approximate, and I think I did this last time as well, something of an approximate nature. Okay, and now we're going to start lofting this in 3D space. So you can see we've got a couple of points, and if we were to just loft this as it is right now, it would look really bad. Oh, it doesn't actually look too bad. And okay, I think I know why it doesn't look too bad. I think, this is my theory, the reason is because the wing that we've created is at 0 degrees, so it doesn't have a dihedral, and therefore this looks natural, but also the shape that we've created in the center. But to make this a little bit more accurate, what we should be doing is adding some guide rails to it. So let's remove the fuselage because we don't need it at the moment, and the nose. And let's adding a little bit more guidance to it. So what we need to do is add a guide rail that will allow this to curve inwards like this. So let's go back to that body, turn on 3D sketch in this case. Fit point spline. And I want to go from here to somewhere here. And what I can do is activate tangent handle. Excuse me. I'm really hungry. But we're going to finish this. We're going to finish this. So let's roll with that for now. So we can edit the loft and add that as a guide rail. And then what we're going to do is we're just going to observe how that would have changed it. Selected rail does not touch all the profiles. And surprise, surprise, I made the exact same mistake last time. And the mistake here is that when we're dealing with control point splines, you can tell that the control points aren't actually part of the surface that we're creating. There are external control points. Whereas if you were dealing with a normal spline, then you wouldn't have been dealing with this issue. So what I need to do is, you can tell that I've locked this rail to the guide rail instead of the actual surface. So I'm going to click on that constraint and remove it, and I'm just going to drag that into the main surface. And ideally, actually, this should be horizontal. Ooh, that's not good. Ideally, this should be horizontal. And let's try to make it horizontal again. Oops, sorry, horizontal. No. If I try making that horizontal, that for some reason moves, which is not good. So we won't make it horizontal. We'll just visually try and make it as horizontal as we can. Okay, finish the sketch. And now let's try and do loft again. Oops, where's that surface gone? Okay, yep. Profile 1 and profile 2. So that's interesting. I'm not sure why. Let's delete this loft. That's okay. Let's bring back that sketch. But for some reason, this is no longer a closed surface. And I'm not sure why. So let's undo and come back to the point. Okay, there we go. So somewhere over here, we lost our thing. So not entirely sure what happened here, but I think we fixed it. And let's see if we can still try and make this as horizontal as we can. No, and it's lost its thing again. I'm not sure why, but let's just undo and roll with it for now and see what happens. So loft and our sketch, which is here. No, doesn't like that either. Okay, let's delete that. Let's delete that as well. Or we can undo to the point before we made that curve. Okay. So now let's try again. Let's try and create a new 3D spline. And let's attach it between this point and that point there. Okay. And let's just check that that is still a surface. That is. Activate tangent handle. Move the point down. This might be too much. Press OK. And now let's see if we can roll with this. So one step at a time. It's okay. This is why we do things one step at a time, that we identify problems. And let's add that as our rail. There we go. Perfect. So we can see now that the entire thing has gone down to adjust to that spline that we created. And in order to prevent the top part from doing what it's doing right now, we need to create an additional rail. And in this case, we're going to do it from the top of this surface to the top of the other surface. So again, remembering to choose the one on the actual surface. To that one there. Excuse me. So if I can do something like this, I think it would work. So again, loft, rail, add that as a rail. And before we press OK, let's see how that actually looks. So it looks okay from that side, from the back as well, from the top. Let's see how it looks like from the top. You won't actually be able to tell anything from the top because the fuselage pretty much covers that area. So if we bring the fuselage back from here to here, you can see that actually doesn't look like much at all. But what we do know is hidden inside this is an absolute beauty. I quite like the way this ends up looking once the fuselage comes in place. Okay, so let's save this. And now we have our wing box ready as well. Cool. So let's try and see if there's anything else we've missed out in terms of main functional components. So we've got our fuselage. So now let's start naming this. We've got our fuselage underscore main. We've got our V tail, as I usually call this, which is the main. Then we've got our H tail, which is the main. Then we've got our engine, which is also the main. The reason why I'm saying main is because when we start creating some subcomponents for this, there'll be things like V tail XYZ, H tail XYZ. Okay. Then this is going to be our engine underscore pylon. See, this is where it makes a difference. Then this is going to be our H tail tip. This is going to be our V tail tip. This is going to be our fuselage nose. This is going to be our fuselage back. This is going to be our wing tip. This is going to be our wing main. And this is going to be wing underscore box. Of course, the wing box could either be part of your fuselage or it could be part of your wing. In fact, this should actually be fuselage box for me. And the reason is because when I 3D print the fuselage, I want the wing box to actually be part of the fuselage instead of the wing. And it makes sense as well, because when you think about it, the wing box is more of a fuselage component than it actually is a wing component. At least in my eyes. I may be wrong. People may have different opinions on that. Okay, I quite like the way this looks now. And I think now is the time that we start adding details. And I'm just thinking at this point that if I were to scale this down now, I would lose access to where the cockpit and the windows and the doors and stuff would be. So alternatively, what I can do is I can start splitting the surfaces in this scale, and then later on I can scale everything down, and then I can start embossing it in the smaller scale. So let's do that. I'm gonna create a sketch in this scale, and I'm just gonna keep an eye out on how the cockpit looks like. So the cockpit's really nice. It doesn't look too aggressive like some of the Boeing ones do. Okay, so it seems like this is sort of a downward, that may be a straight line, that may be a straight line, and that's also going downwards. Okay, so nothing too complex happening there, but again, this is where a good quality blueprint would make such a massive difference. Right now, there's not much that I can tell from this. What I'll have to do is I'll have to rely on constantly looking at these blueprints. These reference images. So that might be a close one to look at. And what I'll do is I'll put this on my other monitor so I can look at it continuously. Where is it gone? Okay. So it appears to be doing something like, okay, we need to switch off the 3D sketch so it doesn't mess up anything. It appears to be doing something along the lines of this goes backwards, goes down a little bit, and then comes back up. Let's try and do that. And it's obviously they're not sharp, they're all curved. So maybe something like that is nice. The next bit seems to be relatively flat. So when I say flat, they're quite horizontal to each other. But the real question is, how many windows does it actually have? So is that 1, 2, oh, and then there's a middle section as well. That's where these things can get really deceiving. No, it doesn't. It's got 4 cockpit windows, but it looks like from here that that's not the case. Okay, well, we're going to follow the reference pictures in this case because there's more reference pictures than there are blueprints for this particular aircraft. So what I'll do is I will probably not make this from this view, and I will carry on from this view. Okay, let's try that out, shall we? So this should actually be going down a little bit more. Yeah, that's what I meant to do. It should be going down a bit more, rounded. Okay, let's do that. Okay, modify, split face, and that's the face we want to split. There we go. DIY family says, hi, super nice to teaching us this. It is a pleasure. Honestly, I do this as a hobby, but it gives me so much satisfaction and fulfillment. Seeing people adopt these techniques in their own ways and creating RC aircraft or doing some very, very big projects for universities or professionally as well. So, immense pleasure. Thank you so much for the support. Okay, let's continue from the front view this time. And what I want to do is I might want to project that line and that line because it seems like you might want to follow somewhere from here. So if we try and go to the front, maybe till somewhere till there. And then we need another line from here, but it's curving in a bit, so it's not exactly. And this one should be relatively. Okay, so let's try that. And I feel like we might run into an issue because of this and this. But before we do that, let's try it out anyways. Okay, but this one should be a different radius. So might do that and that, but give this one a different radius. Did that even work? Yep. .7, but we extended a bit there. Finish sketch. Okay, let's try it out. So modify split face, and we want to split this one, and it might give us an error, but let's see. It did indeed give us an error. So what do we do? So what I think is we can actually pull this bit down a little bit. Edit form. And it's this particular one that's bothering us. So what I'll do is I'll push this to the front a little bit. Bring it down. Finish form. And that allows us now for this sketch to be completely part of that surface rather than also being included in this one. So it was a very minor adjustment, but it'll make our lives a lot easier. So modify, split face, and this is the one we want, and splitting tool is this one. Oh, okay, fair enough. It's still done the same thing. Compute failed. And I think in this case, it's because of the back. So split face with that. And yes, as you can see, this is now going to cause us an issue from the back side. So what we can do is to split the fuselage, pseudo split the fuselage, and then we can join it back up. So the way we can do that is we can create a construction plane from here, maybe till here. And we can use split body to do that. And now let's do split face to this one. And there we go. Okay. So that's good. It's finally helped us. But we can see that if we compare this to this, that doesn't look the most accurate in terms of this section here. So what I'll do is I'll try and edit the sketch a little bit. Bring it back a little bit more. Finish the sketch and see what happens. Okay, that looks more like it. But we can still see this curvature here. And I am not exactly sure why. So from this view, it looks good. But from this view, you can tell that there's a bit of curvature. I mean, the real reason is because of the actual fuselage's curvature. Things that look straight in one dimension will probably not be straight in another dimension. So ideally what would have happened is we made all the cockpit glasses from one single view. So for example, if we made it from here, that would have probably been a better idea. But I don't know, it's not usually worked out for me. But you never know. Let's try it out. So let's go back in time. Might be an interesting challenge to face. And what we'll do is we'll try and do it from the top view. So from the top view, thing is we don't really know what the exact shape would look like. So let's skip this bit. I think that would overcomplicate things too much. Okay, so let's do that. Let's go back into the sketch and mirror this. So let's mirror these elements. And the mirror line is the plane of symmetry, of course. So the origin, that's our line. Press OK. There we go. Press finish sketch. And now let's modify split face. That one, splitting tool is that one. There we go. Now we have a cockpit section as well. Now, what would be really cool, purely for an aesthetic purpose, is to add those lines there as well. And I guarantee you it looks so much better already. But because this is going to be 3D printed, what I'm actually going to end up doing is embossing these, and I'll show you very quickly how I intend on doing that. It's press pull here, and then you just go minus, let's say 0.5. Okay, I'm not going to go down that deep, but you can see that this is something that you can do if you wanted to add depth to a sort of flat object. So let's leave that where it is. Let's hide this sketch now. And of course, the reason why I'm not embossing right now is because we're going to scale the entire model down to a fraction of its size because we want to 3D print it, and then we're going to emboss it. So let's hide the origin. We don't need this construction plane anymore. And let's try actually combining this back into its body. There we go. It worked. So that's nice. We have somewhat of these temporary go-arounds that we can use from time to time. Okay, let's create the door. So the door should be pretty simple. So we'll just make a square. Oh, sorry, a rectangle. And we'll add a fillet to it. There we go. Finish sketch. Modify, split face. Splitting tool is this one. There we go, done. Let's add another sketch. And now we're going to work on the windows. Thankfully, there aren't many windows in this aircraft. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 times 2, 18. And the reason why I say thank God is because if you were here on the previous live, you would have noticed that there were about 200 windows. There were approximately 150 to 200 windows. And the problem with that is that when we are splitting faces with these windows, there's so many splines involved that Fusion itself is inefficient with splines. On top of that, I am recording the screen, and on top of that, I'm streaming it live. So that requires a lot of computation power, and therefore it was being extremely slow. But hopefully that's not going to happen in this case. So let's create a window. And in this case, you can see that there's a lot of, where did that go? That's 06X. That the windows are quite round. So if we look at this one, the windows are quite round. So they're not like the usual airline windows that we might be familiar with. They're more oval, but these ones seem quite round. So let's add, so that's what a normal airline window would look like, but this one seems more like 0.17. Seems more like that. Very subtle difference, very subtle difference. So finish the sketch, modify, split face, splitting tool is this one, and okay. Now what this would have done is it would have split the face on the left side, but also on the right side because it's part of the same surface. Same with the door, as you can see. Okay, just making sure everyone's okay. Cool. Now we want to create a rectangular pattern with the feature, which was the split feature. The axis is this one, and we need 9, so we need 9 quantity. And the last bit is going to be .75. Actually, before I do that, let me save, because we might get into trouble. Rectangular features, split face, axis, and there were 9 that we needed. And if I remember correctly, it was between -5.5 and -6. So let's do -7. Okay, that was actually really, really close. Let's try 6.5. I think that's perfect. I'm actually very, very happy with that. So, cool. I think that's really nice. If we really wanted, one additional thing we could do is add that 6x. But because we're going to 3D print this, none of the livery and the colors are going to show, unfortunately, because I'm printing in a single material. What I think we should do is scale it down, emboss it, and then call it a day. And what I can do later on is I can add some libraries to it, and I can share it with you guys on Twitter, Instagram, and YouTube itself, if that's something that you would like to see. Just thinking if I've missed anything. Don't think so. Okay, so at this point, let's just make sure we save. And this point, we no longer need the canvas. So what we're going to do is modify scale, and we're going to scale all of this. We're going to scale it uniformly, and the point is going to be the origin. The reason why I'm using the origin as the point of scaling is because when we scale it, we're hoping that the scale, the plane of symmetry still remains. So I don't know how much I want to scale it by now, but let's do some quick calculations. Currently, as we know, the length of this fuselage, sorry, the length of this aircraft, let's do a quick length check, is around 26.642 meters. The scale I want this in is about this big. And that is approximately 15 centimeters, if I'm not wrong, which is about the length of a ruler, really. A standard ruler would be 15 centimeters. So if you can see that ruler, this is how big I'd want it. So let's say 15 is our target, or 14. Let's say 14 is our target. So 14 centimeters is our target. So the first thing we need to do, I feel like I'm teaching primary school maths at this point, but you know what? We get this wrong all the time. So what I'm going to do is I'm first going to convert 26,642 into so 26,642 into millimeters. So let me do that. 26,642 meters equals to millimeters. And that, my dear friends, is 26642 millimeters. All right. And at the same time, I'd like to convert 14 centimeters into millimeters, which is pretty standard, 140 millimeters. And the reason why I'm actually using Google to do this is because you don't realize, but you miss a decimal point and everything gets blown out of proportion. So just to be ultra safe, I like to do it this way. Okay, so how much do we need to scale this by? So we've got 26,642 millimeters, which is currently what it is. And we want this to become 140 millimeters. So I'm hoping it's as simple as 26642 divided by 14. Which is 1,903. But because we need to scale this down, it should actually be 14 divided by 26642, which is 0.0005. Okay. Now don't worry, if we make a mistake, we can always verify and check it again. Not a problem. So let's hide that sketch, which we don't need anymore. Modify, scale, all of it. And the point is the origin, as we said before. And we want to scale this by this factor. I may have actually done something wrong. Let's have a look. Let's create a new sketch here, and this is now 0.13 meters, which is still not correct, I think. So let's now convert this to millimeters and do an inspect. And this is 133 millimeters. Actually, that's correct. That's correct. So it's close enough to what we wanted. We can increase the size of this just a little bit if we want. So let's finish the sketch. And now we can scale this up a little bit. So origin off, sketch is off. Origin point. And we can scale this up by, let's say, 1.1. and see if it's closer to what we wanted. Okay, 146 millimeters. That's perfect. And just to confirm, 146. So 146 millimeters is equal to centimeters, and Google says that is why is it doing that? Millimeter to centimeter, 14.6, correct. So let's leave it at that, and I think I'm pretty happy with this. And now all we need to do, all that is remaining, is to actually emboss this. So we don't need the sketches anymore. We can switch the origin off, finish the sketch, press pull, and we can do 1, 2, 3, 4, 5, 6, 7, 8, 9, and the door as well. Let's do the door separately, actually. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to push this in by 4. That's actually that's too much. 4 is too much. So let's do -3 and see what happens. Too much as well. -2. Sorry, -2. Too much. -1. Okay, -1 seems like a good idea. Okay, wonderful. Save that. So I think we settled for, what was it? -1, right? Yeah. So what we can do is we can do the same thing for our doors. So do -1. And the same thing for our cockpit as well. So 1, 2, 3, and 4, -1. Okay, that's looking super cool. And final thing is to just mirror this. So create mirror bodies, that, and that as well. And there we go. Let's create that in your body. And perspective. So, ladies and gentlemen, oh, oops, that was a flop. We need to mirror one more thing, and that is that one as well. Okay, there we go. Now I can say that again. So, ladies and gentlemen, that is our aircraft complete. There are actually a few more things I need to do before I can actually send this to the 3D printer. Quite a few things actually, because if you try printing this as it is in a 3D printer, it won't do it. And there are multiple reasons for that. And maybe that can be discussed in a more, in a different session, if you're interested to find out more. Because there's the art of computer-aided design, and then there's the art of 3D printing. And it's useful to know computer-aided design in order to do 3D printing well. So it's fun. It's a very fun, very, very fun tool to learn. Let me just check one thing. So shaded. Okay, I think that's actually not bad at all. I was worried this might look really strange, but it actually looks pretty good. Yeah, so there are some additional things that I need to do in order to make this 3D printable. But I will do that in my own time. But yeah, thank you so much everyone for joining in. There are still 7 people online, which is absolutely amazing. Thank you so much everyone for your support. Honestly, just you being here is a big support to me. But if you'd like to increase your support, sorry, I'm really hungry, so my body's acting up. But if you'd like to increase the support, please do like, comment, and subscribe. It really helps out. Again, we are trying to target 5,000 subscribers by the end of this year. So it would be really helpful to have your contributions towards that. And Hopefully, I'll be releasing a short video on the Patreon projects that we are planning to do. And for those of you who don't know, Patreon is basically a website. It's a platform for creators like us. And what we can do is we can give out some memberships. So for a very small fee, it's a monthly recurring fee. You For that small fee, you get a range of sort of bonuses from the creator side. So if you want to support me towards the subscription I pay towards Autodesk to make these videos, or for my editing time, or for the time that I'm taking out to make these videos, or you'd like me to improve my videos and you'd like to contribute in that way, for example, getting a proper green screen is something that I've been looking at. All these sorts of things you can support with using Patreon. At the same time, in exchange, you get some exclusive content. So the thing that I'm trying to do in August is whoever joins the Patreon by that time, and we've got 1 or 2 people already, is we sort of come together on a specific date and we sort of kick off a project within ourselves. So one Patreon session that I did last year with somebody was to design a slot car. It was a Ferrari F1 slot car. And that was really, really fun. So what I'd like to do is to make this more of a community thing, where a couple of us come together maybe once or twice a month, and we sort of do bits of the project in our own time, but then we come together on those dates and then we pull all our resources together and do something really, really fun. So that's the plan. If you have any ideas as to what you'd like to make, it'd be really helpful to find out. And another one is the Q&A. So a couple of you asked me to do a Q&A, but nobody posted any questions. So if you have any questions, please post them and then I'll answer. I'll make a quick video or a more elaborate video of the Q&A, and then I can speak about whatever it is that you've asked. It could be about Fusion, it could be about any other 3D modeling software, it could be something professional, it could be something personal, whatever you are feeling like. And that's pretty much it. So those are all the updates. Hopefully you enjoy this. I really enjoy doing these lives. I feel like it allows me to sort of, in a non-prepared way, display what's happening in my mind. And I know a lot of people find this entertaining as well. So even if you don't do CAD and you are here and you're enjoying these videos, thank you very much for being here. I used to tune into other people's lives who were making CAD models, and I used to really enjoy it. So it's an honor and a pleasure for me to be able to do this for you. That's pretty much it for today. So I'll decide which aircraft I want to make in the next live. I've got a couple of options suggested by you all. But if you have more options, more aircraft that you'd like me to make, just put them in the comments and I will definitely consider it. There are some interesting projects coming around, which hopefully I will be able to tell you about in the near future. But I'm very excited to share those as well. All right, guys, thank you very much. I'm going to go and have some dinner. It's been a pleasure. It's been an honor. Hopefully, you will have a great rest of your day, regardless of where you are in the world. Good morning, good evening, good night, and I will be signing off. Thank you so much, guys. Take care. See you soon.